Well, hello again everybody, and welcome to this part 3 of my vintage Stella television restoration. Now in part 1 of this video I did mention that we all stand on the shoulder of giants. Well, I'm very happy to say that I've actually got quite a lot of people helping me with this television restoration, and that includes quite a lot of members of the UK Vintage Radio Restoration Forum. So I'd like to thank all those guys very much who have been bearing with me bumbling along, and thank you for watching as well. Now today's video isn't going to be one of those normal videos where we just repair something, because really I'm going to be taking lots of measurements and basically just making a video of me taking those measurements so that people on the restoration forum can maybe give me some help and advice on what to do next. Now before we get started on the main part of the video, I thought it would just be useful to describe some of the equipment I'm going to be using today. So most importantly is probably this, what they call a standard converter. So this is going to take composite video and it's actually going to produce a modulated output which can drive this old 405 line television, because analog television hasn't been transmitted in 405 line format in the UK now for very many years, so you can't just plug in an antenna to your aerial and expect it to work. You do need one of these special converter boxes. So this converter box is called an Aurora, and what you can do is you can supply composite video into here. It will actually modulate that and drive the television antenna socket. So you can actually watch modern television images, DVDs, videos, etc. It enables you to watch that on an old television, so you do need one of those. Now, the way that these work is if you don't actually have a video signal plugged into it, these default to producing a test card pattern. So this will default to producing what they call the test card C-type pattern, I believe it is. But what we can actually do is I'm also going to be driving this video input using this teletest which you saw in the previous video, and I'm going to be having this set to the grayscale. So when I actually turn this on, what it will be doing is it supplies composite video into the Aurora standard converter, which is then modulated, and I'm going to have this set up to just have this grayscale bar pattern because that's quite a useful test. The next piece of equipment I'm going to be using today is this Fluke 25 multimeter, which is actually quite an old digital DVM now, but I do like these because they are pretty bomb-proof. The main reason that I use this over a modern Fluke is very simple, because all the modern Flukes seem to have this battery saving mode on them and switch themselves off at the most inconvenient moment. Well, this, once you switch it on, it just stays on, and I like that because, yeah, modern meters just turn themselves off at the wrong time. Now the other useful piece of equipment to have when making measurements on vintage equipment is actually an old meter of the correct input impedance. Now there's a couple of types of meters which is favoured in the restoration world. One of them is of course something like an Avo Model 8 or Model 7. It's useful to have Model 8s and Model 7s because a lot of the service data will have been taken on those original meters, and those meters have got quite relatively low impedance, so a digital meter like this will tend to read higher than an analog meter. Now this meter that I'm using, it's not really equivalent to an Avo 8. This is more equivalent to what I would call a VTVM, which is a valve tube voltmeter. So this meter has got a much higher impedance than a standard analog meter because it's got a field effect transistor front end. So it actually looks to the circuit much more like a digital meter or a valve voltmeter, but it's quite useful sometimes just to see a needle moving up and down. If we need it, we have also got an Avo 8, but I'm going to commit sacrilege and say I'm not really a big fan of Avo 8s. You know, it gets tired very quickly changing between ranges. So whenever I can use a digital meter, that's what I'm going to be using. So the final piece of equipment I'm going to be using today is this Tektronix TDS 2022B, which is, again, by modern standards, quite an old and creaky oscilloscope, but it is a modern digital oscilloscope, or digitising oscilloscope as I should say. I do also have access to many analogue scopes, but it does make it much easier to be able to take samples on a digital scope, and that's more what I'm used to using. So on the scope here we've got a traditional ×10 probe, which is here, and we've also got a ×100 probe, which allows me to take much higher voltage measurements. Now, one of the problems you can find with modern scopes is they're actually designed, of course, for working on modern semiconductors and for working on very low voltage systems. They weren't designed for people working on valve amplifiers and valve radios, so they tend to have quite a low voltage per division setting. So the maximum voltage that this will do is actually 20 volts per division, whereas if you look at some of the old scopes back in the day, you'll find that some of them could do 50 or even 100 volts per division. This one only goes to 20. So that's one of the reasons why I'm going to be using this probe on input 2, because it's just a much higher voltage probe and it will actually attenuate that so we can measure it on the Tektronix here. Now, of course, when you're working on vintage equipment like this, it's quite important to get all your excuses lined up and be prepared for when it all just goes horribly wrong. Now, I'm going to start with some of those excuses. You can probably see that my bench here, it's not actually very wide, and basically I can hardly get the television set on it. Some people have been saying things like, well, why don't you look at the television picture in a mirror and stuff like that? Well, the simple reason for that is I don't have anywhere to put a mirror. There's not enough depth on the bench here to get it on. So it's actually really difficult to actually keep going backwards and forwards, turning the television round and trying to get access to the chassis components. But some of you haven't watched part 1 of the video, and I quite understand don't want to watch it or haven't got the time, so you've asked me to recap what the actual symptoms of the problem are. So I'm going to just go ahead and do that. I'm going to reposition the camera and I will show you what the problem is again. I'm going to plug it in now. So I can hear a little bit of hum coming from the television set now. I can see it's drawing about 110 watts. That's rising slowly. So what I'm doing at the moment is I'm just adjusting the brightness control. Now, the brightness control is ganged with the volume control, so when you adjust one it tends to adjust the other. So that's what's happening there. So that's the brightness turned fully up. That's the brightness turned fully down. So I'm going to set that maybe about a quarter of the way up. I'm going to go back to the back of the television now. I'm just going to try tweaking what I think is the contrast. So I can make the picture go brighter, but I can't really make it go as dark as I think I want to do. So this is one of the things that I've been saying. I think this picture looks too bright and washed out. Now that could actually be a problem, because I believe it could be an indicator of being a low signal level into the television. I'm not exactly sure. Now we can actually see that adjusting this contrast control does have a slight effect on, in fact we've actually got, I thought we had it there, we almost got the vertical hold to lock there, and I suspect that's probably due to the way contrast control works. I think it is linked with the AGC action of the set, so it does seem quite interactive, the contrast control, so it's almost holding there but not quite. Okay, so I'm adjusting the vertical hold control now, and you can see that just by adjusting the actual frame oscillator I can almost get it to sync with the incoming video, and sometimes it will sync. And there are periods of time when the television does actually achieve a lock and the picture will hold for a few moments. Let me just try adjusting the actual fine tuning on the set. Does that make any difference? No, it doesn't seem to make any difference really. Okay, so we did actually get the television to hold there by, holding your tongue at the right angle and tweaking all the various controls. I don't think it's right though. You can see we've got some very heavy retracing going on, which I think will correct itself once we fix the problem with the vertical hold. But I think again I'm going to go back to the contrast control. It's just really poor on this set. To me it looks very bright and washed out. That was the tuning control I'm adjusting again. So what I'm going to do next, I'm going to turn on the pattern generator, which is set to grayscale. And we seem to have a grayscale there, but the video is rolling again, or the frame has lost its hold. I'll just change that to a checkerboard pattern maybe. Okay, so as I said earlier, you can clearly see the problem now, that I just can't hold the vertical frame. It doesn't want to hold, it comes very close to holding, but it will not in fact hold. I'm going to go back to the grayscale pattern now. And it's my opinion that this is still very, very washed out, in that the black, which I assume should be black at this end, it isn't black. It's to me that looks like quite a bright grey. It gets brighter and brighter, but we don't achieve any black at this end. Now unfortunately, because my bench is so narrow, I'm going to have to turn this round before we can take any measurements. And once it's turned round, I can't actually see the screen anymore, which is, as you can imagine, quite annoying. So some people have given references to using mirrors and things. I just don't have room to put a mirror on the bench. I wouldn't be able to see it. The television would be right in front of it and block the view. And I suppose I could pull it back a little bit. Right, there we go. I'm going to put the oscilloscope back on top of there. It's quite nice, warm and toasty. Forget how hot these sets actually used to get. So I've switched our television set back on. What we're going to do next is we're going to have a look at some scope measurements to start with. So we're going to have a look at the input to the multivibrator. I'm going to take a look for the synchronization pulse, which should be pulling the multivibrator into sync. So this is one half of the sync separator and AGC valve, which on this circuit diagram is valve number 413 and is an ECL 80 tube. So this is the thing that should actually be stripping out the synchronization pulses, which go to make our free running oscillators. We have two free running oscillators. We have this multivibrator here, which is actually doing the frame. It actually drives the vertical system on the television, and then I think further down here off circuit we also have a line oscillator. So the purpose of the sync separator is actually to make these two oscillators, the frame and the line oscillator, it needs to pull them into lock with the incoming video. If they aren't running at the same rate, you will see the picture slipping vertically or horizontally, as we've been seeing it slipping vertically. So that makes me suspect we've got a problem kind of with the, could be with the multivibrator here, or with the synchronization pulses which go into the multivibrator. So you can see the line here that comes out from the anode of the sync separator valve. It comes out of the anode and then it comes down here into this multivibrator. I kind of recognise that because I used to build transistor multivibrators to flash LEDs using transistors as a kid, and it was pretty much the same arrangement but using transistors rather than valves. So the video waveform that we're looking for is actually shown here in picture number 5. So we're looking for some pulses, some minus going pulses here, which are about minus 60 volts according to this. Now the frequency of these two pulses, they should be about 50 Hertz apart, but we'll see that when we adjust the vertical hold control, we'll be able to adjust the speed of the multivibrator. So what we'll do is we'll have a look at it first without a video signal, then we'll plug the video signal in and see if we can see the synchronization pulses. Now, of course, one of the problems with looking at oscilloscope pictures and images, you're going to always see differences in what I'm seeing on a modern digital scope and what they were probably seeing on the scopes back in the day when they made these waveforms, probably back in the 50s. These measurements weren't taken using scopes with a bandwidth of 100 megs. It probably would have been 10 megs or possibly even less. So we can't assume that the video waveforms will look exactly the same. So this is our multivibrator pulses here now, we can actually see that the multivibrator is free running at the moment. I know it's free running because I've disconnected the antenna to the set. So what I'm going to do next is I'm just going to take hold of the vertical hold control, and we should be able to actually adjust the frequency of the multivibrator. So I'm going to do that now. Okay, so I'm slowing it down. Not only can I see that the frequency is falling on the scope here, that shows 39 Hz at the moment. I can actually hear it. I can hear the television ticking, so I can hear the low frequency. So that's 42. I'm going to turn it up the other way. Let's see how far it goes the other way. Alright, if I actually turn the control to one end, I can achieve a free running oscillator of 56 Hz. If I turn it all the way the other way, we can get it to 26. So it goes between 26 Hz and 56 Hz. Let's see if I can adjust it as close as I can back to our 50. Okay, so we've actually got the frequency adjusted there to 49.9 Hz, so very close to the video. So the frequency is going to be very close to the video frame rate. The problem is they're going to be out of phase of each other. We need to lock the two signals together. So what I'm going to do now is I'm going to plug in the antenna. And you can now see we've got some little ants crawling along. Can you see that? We've got these little things crawling along here. Well, they're actually the synchronization pulse. They're the frame synchronization pulses. Now occasionally they've just disappeared now, and now it's reappeared again. Occasionally those synchronization pulses, they will actually act on the multivibrator and they will pull it into phase and make it lock. Is it going to do it this time? Sometimes it does, sometimes it doesn't. Yeah, it's locked and now it's off again. So it looks as though we're getting about, the size of those pulses about minus 15 volts. So is it just that these pulses are actually too small to pull this into lock? Now it said that the waveform should be 60 volts from the top to the bottom here, so let me just see if we can check that. So we were expecting an amplitude of about 60 volts there. It's actually bigger than that. The amplitude is about 92 volts, so it's quite a bit bigger. Again, I suspect a lot of that has maybe got to do with the measuring equipment that's used and the loading. They didn't have proper scope probes back in the day. They could have been using anything. So looking at waveform 5 here, you can see it does look a lot like waveform 5, but unfortunately the actual amplitude of the waveform is somewhat bigger than this diagram would suggest. It says it's 60 volts, we're actually reading 90 volts. Well, I guess while we're actually looking at the multivibrator part of the circuits, we should follow that commandment that thou shalt check voltages. So we've got a few voltages we can check here. We've got an anode voltage here of I think that's 92 volts. We've also got a grid voltage here which should be -3. We've got another grid voltage on the other side of the multivibrator, which says that one should be -20. Got another voltage on the anode of the second part of the multivibrator. I think that says 90 volts. So let's go ahead and let's check them, and we will write them down. So the first measurement I'm going to take is the anode voltage at one side of our multivibrator. So I'm going to go to pin 1 of the valve, which is the 413A. So 413, which is that one, pin 1. Right, it says it should be 92. I'm getting 99. I would assume that's perfectly good because this is a higher impedance meter. So the next voltage we're going to look at is, I'm guessing that's probably the grid bias, which it says should be -3 volts. So let's have a look at that. That's pin 2. I get -3.5 volts, so that would be fine. Okay, we're now going to go to the second valve here, which is the V414, which is this valve here, 414, and we're going to look at its grid voltage, which should be -20 volts on pin 1. I'm actually only measuring -17. Is that in the ballpark? Is that close enough? Again, leave it in the comments. So the next measurement is the anode voltage of that valve, which should be 90 volts. So let me make that measurement. 90 volts, anode voltage is pin 9. Well, that seems to be giving me a low voltage there. That should be 90 volts. So I'm not getting 90 volts. I'm actually getting, I'm only getting 70. Now it looks as though that's connected via the height control adjustment. So maybe if I adjust this pot, that voltage will go up or down. Which it does. I can actually adjust that to 90 volts. So I'm going to go back to my crib sheet, which came from the Vintage Radio Restoration Forum. So I've got some usernames here, and I'm going to read out the comments that they've left me and what they want me to have a look at. So we're going to start off with Mr. Heater Cathode Short. So he says, could you post a picture showing the actual symptoms on the screen? Yes, I've done that, haven't we? We've got that video. And he goes on to say, sync problems are rare on a TG100 series. So I'm guessing that this television, I just know it's a Stella television, but they call it a TG100 series television here. So he says that sync problems are rare on a TG100. Well, I guess I'm just lucky, because I've got a sync problem. It would be interesting to see one. Well, there you go, you've seen the sync problems there. Odd operation of the contrast control may be due to fitting of an EF80 in the common IF stage V103 in place of a variable mu EF80, worth a check. He goes on to say, have you checked the installation of the sync coupling capacitor C610 connected to the control grid of the sync separator valve pin 9 of the V413B? The EC80 valve, which is that valve there. No, I haven't checked that yet. Let's look at the circuit diagram. It says that we should have minus 12 volts on that. So I guess if that capacitor is leaky, we would have a much different voltage. So let's go and find pin 9. Okay, well it says it should be minus 12 volts. We're getting minus 19 volts, which again could be maybe something to do with the impedance of the meter. Okay, well with the AVO it reads minus 20 volts at the moment, but it does look as though that thing would be affected by the voltage on the by adjustment of the contrast control, because there's a potentiometer which I think is the contrast potentiometer, so we could try adjusting that and see if it has an effect. Can I get this clip to stay on? So that's the contrast potentiometer, and of course one hand in the pocket at all times. Well, that's not contrast, it's that one. Okay, so I can adjust it between 9 volts and 50 volts. I'm going to set it back to, it says about 12, doesn't it? So I've set that back to 12 volts. So we can achieve a minus 12 volts. Now he's told me that we need to check that they've got a variable mu EF85 installed in place of V103, because it said it was quite common to fit an EF80 valve instead, which is the wrong valve. So he says we need to check we've got an EF85 fitted. So I've switched the television off, I've unplugged it. I think I'm going to have to let it cool down, aren't I now, and then we can open it up and check that valve. So this is V103. So I've just removed that valve, and it is a Mullard EF85, which is the correct valve. Now I think I did say that some of the valves here looked as though they were quite worn. This is very black at the top of the envelope, and I have to admit I'm not really sure if that means that sometimes valves look like this when they're very old and worn out because they've been in use a long time. But you can also get quite a lot of staining on them because that's how they are. Sometimes when the getter ignites to draw out the last bit of the vacuum, sometimes you get that. So again, I'm not really experienced enough to know, but certainly the envelope at the top of the valve is quite heavily metallized. So okay, let's test this valve. So the first thing you do is you press the short button. Now if there's a problem, this short light should come on here. So that isn't lighting up, so that looks good. The next one that I press is grid leakage. So that's still in the good for the grid leakage. And then let's do an emission check. And for emissions, that valve is reading good. So I'm going to say we've got a good valve there. I think while we've got the valve tester out, it would be silly not to go ahead and test the sink separator and the multi-vibrator valve, because we've got the tester on the bench now. Okay, so I've gone ahead and I've pulled our PCL82 valve. So let's just look that up, PCL82. So 16, okay, 15 to 20. I haven't got a 16, hopefully that's alright. 15 to 20. C 6, and we use socket 3. Okay, nothing for shorts, nothing for grid leakage. Is that going to start leaking when it warms up? Let's just see. Nothing for grid leakage. Let's check the emissions, and it's showing good for emissions as well. So I've gone ahead and I've taken out our ECL80 valve, which is a combined multi-vibrator and also part of the sink separator circuit. So let me just check I've got this right. ECL80 should be 6D 6J. 6D 6J. And socket 3. Surprisingly easy to actually misread a line and put the wrong thing in. That's reading okay for shorts. That's reading okay for grid leakage. And it's reading good for emission. Now, with the exception of actually checking the insulation of capacitor C610, we've actually done everything there which heater cathode short suggests, although he did say that it has to be 100% correct to get good action. The reason I don't like disconnecting things is because you can often damage the tag strips, and I don't have any spares for these capacitors, so I don't really want to touch them until I have to, so I might come back and check that later if we don't find anything else. So the next comments I've got are from 1100 Man, and I know his name, this is Nick. So Nick says that he enjoyed my last video, he thought it was interesting. Could be a low emission valve, have you tried another? No Nick, I haven't tried any other valves because I'm very limited with what I actually have. But hopefully that doing that emission test should have given us some confidence that the valves are okay, but of course it's not as good as actually exchanging a valve. So while we're looking at the sink separator circuit, we may as well take all the other measurements for it. So we've got this potential divider here which goes between the I think that's a plus 200 volts supply and 0 volts. It says it should be 24 volts and I measure 24.7. The next voltage we're going to look at is a control grid. Well, that shows it as being minus 10 volts. I think that might be minus 12 or minus 10. It's got two readings here. It says minus 12 volts, or I think it's minus 10 VV. I think when it says VV it means valve voltmeter. So again, I've measured with this with a DVM, and the voltage here does vary depending on where you set the contrast control to, and I found that I can actually adjust that between minus 7 volts and minus 52. So what I've done, I've readjusted it until it says minus 12. So that's the adjustment there for the control grid. The next voltage is again this voltage here, which is kind of a potential divider but feeds in again to the control grid. It says that that should be 10 volts. Well, when I adjust this this potentiometer here to achieve 12 volts here, we do get 10.7 volts there. So I should say minus 10.7 volts. So that looks near enough to be correct. So looking at grid 3 of our valve, pin 7, not exactly sure where that comes from, but it actually says that it should be minus 3 volts measured with a valve voltmeter. I measure it at minus 2.6, which I'm guessing is close enough to 3. Our next voltage measurement at the junction of R403 and R402, it says that should be minus 4 volts. I measure it as minus 3.2. And the final voltage measurement that I have to do is pin 6, which is the anode of the sink separator valve. Now this one actually feeds up into and is actually the sink output pulse that goes to the multivibrator. So this is what should be driving and syncing our multivibrator. And when I actually measure this, I get something a bit surprising, or what I think surprising. So it says here that this should be 62 volts. Well, let's find out. Let's use a Fluke 25 to do this anode voltage measurement, which is on pin 6. 1, 2, 3, 4, 5, 6. Now it should be 62 volts. Well, with this digital meter it's actually measuring 1.8. So 1.8 isn't correct. The next thing I'm going to do is I'm going to use our AVO meter just to double check that. Starting off on the 100 volt range, and the needle is barely moving, so I'm going to have to set this down a range. We'll go on the 10 volt range. So on the 10 volt range it's measuring about 1.5 volts. So again, it isn't reading our 62 volts, which the data sheet says it should. Taking a look at our oscilloscope here, we can see that the waveform isn't totally dissimilar to figure 4, although it looks as though in figure 4 they've actually clipped off the top part of the display. I'm not sure why, but yeah, I think they've clipped the top off. It could also just be, again, because the type of oscilloscope they were using just wasn't sensitive to that little high-speed section there. But we can see we've got some movement, some ripples coming along here. I'm fairly sure that this ripple here is actually coming back. It's coming back from the multivibrator back into the sink separator. It's kind of back feeding, if you like. Now you can see we've got some peaks here, here and here, these 3 peaks. I think that those are actually the decoded frame pulses from the actual television video. Now this dip, it should be around the region of minus 60 volts, but the total height of this waveform is only approximately 30 volts. So if we're not getting a if we're not getting a big change in voltage, if we should be going from, I don't know, from 60 to 0 volts, that's not the same as going from 30 to 0 volts. And when that gets fed into the multivibrator, that could be why our sync pulse just isn't big enough to make the multivibrator lock. Previously we did just check all these voltages here and they did look about right, didn't they? So the only one that really looks wrong is this anode voltage, which again on here it says it should be around 60 volts. We're measuring around 30, and on the DVM and also the AVO meter it's actually only reading about 2 volts, so we're certainly not getting what it says it should be. Now the question is why. So the actual anode is fed through this resistor here, which is R407. So of course we need to check that R407 hasn't gone high, because if it's gone very high, then it won't be able to pull up to the 60 volts that we require. So we need to check that the resistance of R407 hasn't gone high. But I think while we've got the television switched on, we also need to check this rail here, which should be, I think, 200 volts. So let me go ahead and check that now. Okay, so this Fluke 25 meter has been on all day and it hasn't tried to switch itself off once, which is what we want. Just to confirm that low reading, pin 6, 1, 2, 3, 4, 5, 6. Yeah, 1.5 volts. So that should be leading into a resistor, which is, okay, follow this blue wire down, which is there. Opposite side of that resistor, we should have 200 volts, I believe. And we are measuring 206 volts. So yes, we have the correct supply rail to the valve. Let me switch off the television set and check the value of these resistors. I'm pretty sure they're going to be perfect. The reason being is I can see I changed one out previously, so I've already done that. Let me turn it off and double check though. Well, I'm expecting, I think that should be 1.8k, and I'm actually reading 800 megohm. Is that a problem? I could have swore I'd checked these. Is it possible? I don't think that's being shunted by something. I think I've got to get that out, haven't I, so we can take a look. I don't know, something going on there. I'm not getting proper readings. Is that our problem? Could be, couldn't it? Let's take the other side off it and let's swap it out. I'll feel a real idiot because I actually went through all these components and I've written down measurements for them and I thought that I had them right, but yeah, maybe I haven't. I always second guess myself reading resistor colour codes, but that is in fact okay, 177k. Let's go back to the one we've just pulled out of circuit. That's reading 10 megs. That is not right, is it? Okay, we changed out that resistor, so that was surely a problem. It was measuring probably 10 megs, it should have been 180k, so it was out by a factor of 10. So let's see if we can measure that voltage now. So we need to be on pin 6, 1, 2, 3, 4, 5, 6. We were looking for 60 volts and we've got 65.4. So I'm going to call that a winner. Now the question is, have we now got a stabilised picture? Fingers crossed we have. The only thing is, I can't show you because I can't turn the television around the way it is. So I'm going to have to switch off and move everything out of the way and we'll see if we've got a picture now. Well, I wonder what we'll get. Let's plug in. Your guess is as good as mine. Are we going to get a picture? Oh, I can see a flicker. Oh, is there a picture there? Something there, isn't there? Well, would you believe it? We've got a picture. It starts spinning round. I am television repairman. Isn't that the most fantastic thing you've ever seen? Okay, maybe not. It's the most fantastic thing I've ever seen, put it that way. Still seeing quite a lot of what I would call retrace lines. Okay, so I don't seem to have any problems now achieving lock. But it looks as though the lines of the screen, they wide at the top and they narrow at the bottom. Do they call that linearity? I don't know. Now it also seems that the picture is very flickery at the top, whereas it seems, I don't know, more steady at the bottom. Okay, so I've adjusted the contrast. The contrast looks better now, but we've actually lost our line, haven't we? It's shifted to one side. Can we get our horizontal hold back? Okay, well you can see we've got our picture now. Now I've adjusted the contrast and I think that's better than it has been. Do I need to turn the brightness down a bit? It looks a bit too bright, that to me. I don't know. Still getting used to playing with a television. That looks better for my eyes, maybe a little bit brighter. So I think that the picture looks kind of jagged. You can see it's bouncing around. Yeah, that's the best description, isn't it? It's bouncing around. Okay, it does seem relatively easy now to make that hold. It's got a very strong lock. Let's have a go at the, I think this next one is height. Is that about right? I'm not sure. Let me just reach over, see if I can reach over without killing myself. I think one of these controls is horizontal hold. Don't really think that has a lot of effect, does it? A little bit maybe. And the one next to that is a limiter, which I think is only to do with ignition noise, so probably won't do anything. Well, I'm sure you'll agree our picture isn't perfect. It seems distorted at the top but quite good at the bottom, so it needs some further investigation. But I think I'm going to call it a day at that for today, because we've solved the problem that we had, which was very simply down to a high value of resistance in the anode of our sink separator valve. Now I don't understand how I missed that, because I did take some time to measure all those resistor values and write them down. But somehow I managed to miss that resistor value had gone high. But I guess it shows you the power of fault finding. We went through the manufacturer's instructions, we hooked up the oscilloscope and we measured until we found something that looked wrong. And it did look wrong, and it was wrong, and we fixed it. But I can't really take a lot of credit for this. All the credit goes to the people that helped me at the UK Vintage Radio Restoration Forum. So I've got a list of people here. So heater cathode short, Nick, which is a 1100 man. Nick actually gave me an awful lot of information which I did plan on going through today, but before I got to Nick's information it seemed that we found that bad resistor. So I do need to thank Nick, who's been very patient with me, and he's given me a lot of information which I'm not going to go through today. I also need to thank one of my friends, Derek, who was actually, I think he actually did call this correctly. He told me to have a look at that anode load resistor, so maybe Derek's a bit psychic because I think he got it right. And also to I think it's Fernsay, who again put a couple of posts up helping me. So thank you to all the individuals who took their time to leave comments on the forum. Thank you very much, it was much appreciated. You do realise that now we've actually got this vertical hole problem solved. I'm now going to be posting a whole lot more questions about how we got to get this picture working a little bit better. But for today, I think that'll do. You know, really what I need to do now, we need to watch some Doctor Who, don't we? Because you've got to watch Doctor Who on a black and white set, so let's do that.
It almost got to the stage where I deliberately wanted to trip her up.
Something like that happened a couple of weeks ago. To the problem that's set, Susan.
I can't, Mr. Chesterton.
We're looking for a young girl. Where?
Good evening.
What do you want? Which is it? Which is the control that opens the door? You still think this is a trick? I know that free movement is a fourth dimension of space and time. It's a scientific dream I didn't expect to find solved in a junkyard. For your science, schoolmaster, not for ours. You're welcome.